The spanning tree protocol is really useful when you want to have redundancy in your network. You want to have backup paths, backup links, backup switches, but this causes potential loops in the environment. In this case, the spanning tree protocol has recognized there's a loop in the environment and it's shut down one of the links. This is what we want the spanning tree protocol to do. So right now, when PC1 pings PC2, it takes that pathway. Now, what if the link goes down between S1 and S2? Well, in that scenario, spanning tree protocol will recognize that the link is no longer there, and then it will take that blocked port and change it from blocking to forwarding, and now we have our alternate path to reach PC2, and redundancy has been achieved. Now, what happens when we don't have spanning tree protocol? S1 will forward a packet to an unknown destination out of both ports, except for the one it came in on. The packet will reach PC2, but notice that S2 and S3 are similarly forwarding the packet, and the packet is going around the switch network. A second version of the destination packet hits PC2, even though it already got the first one. Notice the packets going back to S1. S1 is now getting false information into its CAM table as to the location of PC1 and PC2. PC1 receives this packet that it sent to PC2 back at itself, and the process begins again, duplicating on the network. PC1 and PC2 keep receiving duplicates, and S1, S2, and S3 are confused as their CAM tables continue to fluctuate, causing an instability in the MAC address table. This will eventually shut down, essentially, communication on the network, causing a layer 2 broadcast storm. This is what happens if we don't have the spanning tree protocol. If we turn the spanning tree protocol back on, order is restored, redundant links are blocked, and we have a path through the network. Okay, let's test this out on a live network. I set up my home network to mimic the topology for the spanning tree protocol. I have 3 switches that are connected to each other, creating a loop or redundancy in the network. I'm located at PC1. I also have a console connection to S1, and my IP address is right here, 192.168.1.100. I connected a second PC to switch 2, and it's located at 192.168.1.101. Now, S2 is the root bridge, and therefore S1 has an alternate port in blocking mode right here. Let's take a look and verify what's going on. And then what I'll do is I'll disconnect the Ethernet cable connecting S1 and S2, and we'll see if the spanning tree protocol will recognize the broken link and then reactivate and take the blocking port from blocking to forwarding, thus adding redundancy and allowing the packets to travel across the network. So let's verify, first of all, that everything's working. All right, here's my command prompt, and you can see that I can ping PC2 at 192.168.1.101. Also, I have a console connection using PuTTY. Let's see here. I'm in S1 right now, and I'll type enable, and then I'm going to put in the command show spanning tree VLAN 1. And when we do that, you can see that the root ID and the MAC address of the root bridge, this is not the root bridge. This switch has port 2 in the alternate role in blocking mode, or the status is blocking. So I am the switch here, S1, and this port is blocking. Now what I can do is I can telnet over to the root bridge, the boss switch. We'll telnet over there. and we'll verify that it is the root bridge. And you can see it says this bridge is the root. I'm in S2. All right, so what I'll do, notice all ports are in forwarding mode. All right, I'll exit out and go back to S1. So now what I'm going to do is I'm going to disconnect the Ethernet cable connecting S1 to S2. All right, there goes the cable. And you can see that a link just went down. So we'll do a show spanning dash tree VLAN 1, and you can see that we've lost a switch port. And notice this is in learning mode, status learning. So it's changing from blocking, notice port 2, to learning. And then if I put the command in again, now it's forwarding. And now I should be able to ping PC2 once again. And I can, except this time, the path that it's taking with the broken link is this way.